All right, in these notes today, we're going to be looking at 2.6, which is graphing systems of inequalities. And today we're going to talk about how to determine the set solution of a system of inequalities in two variables by graphing. So to start off with, we're going to look at this word problem. Students are selling caps, C, and bumper stickers, B, for a club fundraiser. We're going to write an equation or an inequality to express each constraint. So the first constraint tells us they cannot buy more than 144 caps. So C is for caps. So the number of caps that they can have is going to have to be less than or equal to 144. It's okay if they buy 144, they just can't buy more than that. All right. The next constraint says they must buy at least 200 bumper stickers. So that means the number of bumper stickers has to be greater than or equal to 200. And then lastly, they want to sell a combined total of at least 400 items. So that means combined C and B together means we're going to add those two together. C plus B has to be greater than or equal to 400. All right, so that is how we set up that equation or that system of inequalities. So to look at the notes, talking about systems of inequalities. Before we can go into systems of inequalities, we got to talk about how to graph an inequality, just to refresh our memories. All right, so to graph a linear inequality, first thing you're going to do is graph the boundary line, which we get it in y equals mx plus b. We got to get y by itself. And then we're going to use the sign to tell us about the line to use and which way to shade. If the sign is less than or equal to or greater than or equal to, we use a solid line. If it does not include the line, then we use a dashed line. Then we're going to shade the appropriate region. Always you can use a test point. 0, 0 is usually the easiest one to use unless the line goes through 0, 0. But if the test point is true, then you will shade that region. If it's not a true statement, after you run the test point through, then you shade the other region. Also, just cheat or hack or whatever, if you are doing linear inequalities, if it says y is greater than, you can shade above. If it says y is less than, you can shade below. Now, the next thing, the region of feasibility that is the overlap or the convergence of the shaded regions. So we're looking for an overlap. That's where all of our good solutions are. So the system of inequalities here, we got y is less than or equal to 4x minus 3. So we're going to start with a y-intercept of negative 3, a slope of 4, which means I go up 4, and to the right 1. And then I can go down 4 and to the left 1. I'm going to use a solid line to connect those. And for that, since it's less than, I'm going to shade down. So I'm going to shade the region below that. So everything over here, below this line, gets shaded. Now I'm going to look at negative 2y is greater than x. Now, remember, we got to get y by itself in order to graph it. So I need to get that negative 2 over to the other side. So I get y is, I'm going to have to flip the sign because I'm dividing by negative. So y is less than negative 1/2 x. Now, the y-intercept for this is going to be at 0, 0. And my slope tells me to go down 1 and to the right 2. All right, and then my sign tells me that it's less than, so we're going to use a dashed line. All right, and we will shade again below because it's less than. All right, so we are going to be looking for this overlap. So this purple area here in the bottom right is where all of our solutions are going to lie. And again, line 1 is solid because of the sign was less than or equal to. And line 2 is dashed or dotted because the sign was just less than, not less than or equal to. All right, moving on here. System inequalities, 1/2 x minus 3. So we start at a y-intercept of -3. Use a slope of 1/2, up 1 to the right 2, down 1 to the left 2. And since that's less than, we're going to use a dashed line. And it is less than, so we are going to shade below. All right, then the next line, -x plus 2, and -1, so we go down 1 to the right 1. So it looks like that. And that's a solid line because it's greater than or equal to. So we just connect those dots. And we're going to shade above because the line is greater than. And this purple region again is our overlap. Line 1 is dashed or dotted because the sign was just less than, not less than or equal to. Line 2 is solid because the sign was greater than or equal to. And then 1 point in the solution region, anything in that purple region is going to work. Not points that are on the dashed line, but points that are on the solid line would also work. So we could just say like 8, -2, just to pick one right in the middle there. 8, -2. So right there, that's a good solution, 8, -2. All right, next, system of inequalities, y is less than -3x plus 2. So plus 2 goes there. Slope of -3 means we go down 1 into the right, or down 3 into the right 1, I should say. And it's going to look like that, and it's going to be a dashed line again. All right, and then we are going to shade below because it's less than, so we're shading below the line. All right, and then the second line, y is greater than or equal to -1. Now, there's no slope, so we start at our y-intercept of -1, and there's no slope, so let's just all run. So it is a solid line going straight across at the y value of -1. And it says that y is greater than, so it's above. Oh, don't want that thing. I want that one. So it's going to look like that. And again, the overlap, that purple region, is where all my good solutions lie. So anything from that purple region would be a good solution, including 0, 0. So 0, 0 would be a good solution there. All right. Anything on the dashed line would not be a good solution. Anything on the solid line would. So you could do 0, -1 is a good solution. 0, +2 is not a good solution because it's on the dashed line, so it doesn't work. All right, example 4, solve the system of inequalities. We got 3 inequalities on this one. So we're going to start with the first one. We got +5 is the y-intercept, Slope is negative 4/3, means I go down 4, and to the right 3. And then that's going to be enough, and that's going to be dashed. And we're going to shade that one below. Just like that. The next inequality, x minus 2. So we have a y-intercept of negative 2, a slope of positive 1. It'll look like that. And it's going to be a solid line. And we are going to shade above on that one. All right. So purple region is the region of feasibility. So anything in the purple region so far we've already narrowed down our possible solutions. The last thing here, x is greater than 1. All right, so an x value of 1 is where we're going to start. And it's going to be all x values greater than 1. So we're going to have a dashed line going up and down this x value of 1. And it's everything going to be to the right of that region. So our solution set is just that small little triangle. I'm going to color yellow. No, that didn't come out very good. See if I can. Might be able to zoom in and make it smaller here. So this small little triangle here, that's where all our solutions lie, right in the middle. All right, so 2 points in that solution region. Well, the only one that we can say for sure looks like 2, 1. And then points on the solid line will work, so we can use 2, 0 as well. Remember, solid lines are included, dashed lines are not, so both of those are good solutions. All right, lastly, we're just going to write a system of inequalities. We don't need to solve anything here. A company manufactures 2 types of products, product A and product B. Each unit of product A requires 2 hours labor and 3 units of material. Each unit of product B requires 4 hours of labor and 2 units of material. The company has 80 hours of labor available and 60 units of material available. So that's as much as they can have. 80 hours, 60 units. A is going to be product A, B is going to be product B. So it's 2 hours of labor for product A. So for the labor inequality, we're going to do 2A, and the labor for B is 4 hours, so 4B, and that has to be less than or equal to 80. And then as far as material goes, we need 3 units for A and 2 units for B, and that has to be less than or equal to 60. And that is our inequality. We could solve that by graphing and find good solutions once we put it on our graph. But that's not what we needed to do. All right, example B here. Farmer wants to plant 2 types of crops, wheat and corn. Each acre of wheat requires 2 units of water and 3 units of fertilizer. Each acre of corn requires 3 units of water and 2 units of fertilizer. The farmer has 100 units of water and 90 units of fertilizer available. W is wheat, C is corn. All right, so for water, so this is going to be the water one. We're going to have 2 units of water for wheat, so 2W. And for corn, it uses 3 units of water, so 3C. And we only have 100 units available, so we have to be less than or equal to 100. So that is our water inequality. Then our fertilizer inequality, wheat requires 3, so 3W. And then corn requires 2 units of fertilizer, sorry. So 2C, and that has to be less than or equal to 90. So that is our system of inequalities. If you have any questions, please don't hesitate to reach out and try to get some help. Love to help you out. Talk to you later.